some of you who don't have access to that are sitting next to somebody who does have access to that. I'm going to close this guy out here and get rid of that. No, I don't want to save anything. Okay. And we're writing. All right. So when I usually start talking about quadratics, I'm gonna, and the book doesn't quite do this. It's kind of, I was looking at it today. It's a little different, but what I'm going to do is give you the 3 forms that there are. The first one is just a general form for it, and it's probably the most popular one as far as the way you see them. Okay, so that's general form where A, B, and C are just regular, our numbers. Okay, so that's general form. Then another one is vertex form. There. I'm trying to make this a little clearer. It is an H, and this is a K. Oh, it's sliding over the place. Okay. And finally, factored form, which is another form that you have seen already. Now, when some of you did that other activity and you had to do the McDonald's Golden Arches, a lot of you chose this form, this vertex form. Okay, so you've seen this before, all right, and you've used it, and that's good because graphically it's the best form to use. It tells you a lot more about the graph than any of the other 2 forms. Okay, if you want to solve something, you most likely want it to be in general form. And that's how most of your quadratics are going to be. All right, but vertex form is the best to use when you're modeling or graphing stuff. Factored form is not bad. It's probably the second best one as far as graphing goes. It's just the A value on that is not, doesn't give you the distinguishing parts of the graph like vertex form does. Okay, vertex form is named vertex form because H and K is the vertex. All right. Here, this little C sub 1 and C sub 2 are the x-intercepts. And there's really not a whole lot to the general form. Okay, so here's the kind of stuff that they're going to ask you a little bit about. Find the, find the vertex. I'll put little bullets there. State axis of symmetry, they call it. And I think is that all they're going to ask you to do? In the beginning it is. All right, we're going to run with that. Okay. All right. So, let's do that. So I'm just going to pick one. In general form, So we're going to graph that. All right. So I'm going to go into decimals. I think my decimals is already. Oh, wait a minute. It won't let me do that, I don't think. Oh, maybe. Let me try. Hey. What's the equation? I'll let you know. Y equals x squared plus 4x minus 6. So x squared plus 4x minus 6. So there's my graph. So here's the vertex right there. All right. It's also called a minimum because the graph never goes below that point. So it's called a minimum. If we want to get it, we would just tap, and it will tell us what it is. I have -2 and -10. Vertex, -2, -10. In this case, that's also called a minimum. All right. Now, I always think it's a good idea to say the minimum is a point. Okay. There's a number of different answers, and some, well, most books are going to go a point, but some might say it's -10. Okay, but I like to give it as a point. Axis of symmetry. The axis of symmetry goes right down the middle of the parabola. This is the graph of that quadrant called a parabola, so it goes right down the middle of it. Since it is a vertical line, you would say x equals -2, because it goes right where the vertex is. That would be called the axis of symmetry. So let's try another one. Same thing. This time we'll go y equals -2x squared plus 8x plus 9. Okay, we're going to do the same thing. Vertex, axis, okay, I'm going to go back into my decimals, going to graph it. I'm just happy that it's working. Okay, so I had -2x squared plus 8x, excuse me, plus 9. Come on. Plus 8x. Gosh, 8x plus 9. Okay, so I'm going to go up here again, go find that vertex. There it is. 2 and 17. So the vertex is 2 and 17. In this case, since the parabola goes like this and opens and comes back down, that's called a maximum. So in this case, this is called a maximum. And the axis of symmetry, same thing, right down the middle. So we look at the x-coordinate of the vertex, 2. And that's how you do that. All right? Graphically, that's how you do it, I should say. Questions on that part right there so far? Okay. Let's look at non-graphically. So this would be not using a graph. I'm going to do the exact same ones. Let's see, that was x squared plus 4x minus 6. To find the vertex, there is a little formula you can use. When it is in this form, it's negative b over 2a finds the x coordinate, and then we're going to do, they use function notation for it. I'm just going to say, leave this blank and say sub in x. All right? So what does that mean? Well, first of all, this is in this form. So a and b are these numbers here. Whatever's in front of the x squared, whatever's in front of the x. So what would a be? 1. And b is? 4. So what I'm going to do is use this formula. So I'm going to go negative 4 divided by 2 times 1, which is negative 2, comma. Now it says to sub in the x. So now what I'm going to do is take that negative 2 and put it into this equation. So I'm going to go negative 2 squared plus 4 times negative 2 minus 6. All right. So I type that right in using a calculator or whatever you want to do. Maybe we don't need one. Let's see. Negative 2 squared is 4. 4 times this is negative 8. Negative 6. Looks like I get a negative 10 out of that. Hopefully, that was my answer when I found it before. Was that the answer from before?
Yeah.
Yeah. So you can do it by hand. That's one of the ways. Use the negative b over 2a. Find the x. Substitute it in. It comes out with the answer. Oh, and the axis of symmetry, of course, is the same thing.
So it's negative 2, negative 10?
Yep. Okay, let's try the other one. Y equals negative 2x squared. Go back and see what it was. What's going on?
The parenthesis next to the 4.
Oh, that's a negative 2, sorry. I'll clean it up for you. Try anyway. There we go. I can stop a little bit here, slow down. Okay, so we're going to find the vertex. Use the negative b over 2a. A is equal to, b is equal to. What's a equal to? Negative 2, good. And b?
Negative 8.
Oh, it's just 8.
Oh, yeah.
Yeah. Okay, so now I'm going to go negative b over 2a. So I'm going to take that negative 8. 2 times the negative 2 on the bottom. Let's see. By gosh, that's 2. All right, so there's the x coordinate of the vertex. Now, how do we get the y? Substitute it in. Did they do this in 65? Do you guys know? Do you remember? Did they do it? Yeah? Some? Yeah? Okay.
The vertex version for like a day. There you go. All done.
So then we'll go here. 2 squared is 4 times 2 is going to give me negative 8 plus 16 plus 9. Let's see. 17. Was that my answer? Yeah. So it works. And of course the axis of symmetry is 2. Okay? Yeah. Okay. I think they do mention this, so I'm just going to do it as another way of doing it. But what we're going to do is call it converting general to vertex. Okay, so this is be another way that you won't like it as well, but it's pretty much doesn't really specify. I couldn't find any problems anyway. It said to do it this way, but I'll show it to you anyway. Again, I'm going to take that very first one. Let's see, what was that? Oh, come on, 4x minus 6. Oops. All right. So what we want to do is take this and convert it into vertex form. So the vertex form was this. And here's the technique to do it. So the first thing we want to do is take the constant, which is the 6, and add it to both sides. So we get y plus 6 equals x squared plus 4x, like that. Okay? So you always want to move that constant out of there. Then what we're going to do is take half of b. So half of b, which is 4, half of 4 is going to be 2. I'm going to write it there and circle it. You'll see why. And now what I'm going to do is square that number. So I'm going to square 2. That gives me 4. I'm going to add it to this side, but if I do that, I have to add it to the other side to balance. So I keep a balance.
You lost me.
Well, let me finish it, and then I can just kind of show you what we did. Okay? You just got to trust me on it. All right. What's on this side? This is going to be y plus 10. What we're going to do with this side is we're going to rewrite it. Okay? And here's how it's going to work. So it's going to go parentheses x plus that number that I circled squared, because I'm going to change colors here for a second. X plus 2 times x plus 2. If I FOIL that, I get x squared plus 4x plus 4. So they're the same thing. So the objective of this whole procedure is to get this. So that's why we moved the 6 out of there. That's why I took half of 4. That's why I squared it. 2 squared is 4. So I add 4 here and I add 4 here. Now I have what is called a trinomial square, if that means anything to you. But what that does is it allows me to write this part like this. So it's x plus 2 squared. It's always going to be whatever that number is. And now, if we just subtract 10 from both sides, oops, go back
So h is half of b.
H is half of b. You are correct. And now it's in vertex form. And there's the vertex. All right? So that is another way of doing it. that technique is called completing the square. And I'm pretty sure you did that in Math95. I'm not 100% sure. And usually it's used to solve quadratics, but it is one of the worst ways of solving them. Probably wouldn't want to solve them that way, because you'd want to use a quadratic formula. It actually doesn't make any sense to solve them that way. But it does come up in other higher level mathematics. They don't really mention it here too much in far as the first section, and they just kind of, I think it's in the second section. They do have using to write convert, but I don't know if there's any actual problems where it says to complete the square. So I don't know, they mention it, but they don't really have you do too much with it. Okay.
Question about the second step. So half of b is 2, but then if you square 2, you get like 1.4.
If you square 2,
You get 4.
2 squared is 4, right? 2 times 2.
Oh,
You're taking square root, huh?
yeah.
Yeah. Oh, we're squaring it. Okay, so there's that. So there's a couple ways to do it, all right? But in the first section, all they want you to do is find the vertex. So if you're going to find the vertex, how should you do it? Graph, right? Or what's the other way? It's pretty easy. The negative b over 2a. All right? So you pick. So when you come down to the problems on 426 and it says find the vertex, and we can do one more or two more, I don't care which way you do it, it just says to find the vertex. So you can either graph them or you can do negative b over 2a. All right? But I sure wouldn't complete the square unless asked me to. So let's do another one with the negative b over 2a. Y equals 3x squared minus 4x plus 5. There we go, 3, 4, 5. Okay, so we're going to find a vertex using the negative b over 2a. A equals, b equals. What is a equal to? Not, it's just 3. What's b equal to? Negative 4. So now I'm going to find the vertex using the negative b over 2a. So negative b, but it's already negative, so that means 4 over 2 times 3. Excuse me. So that's going to be 4 over 6. 2/3. All right, that's a good idea. 2/3. Now how do we find the y part of that? Put it back in. Y equals 3 times 2/3 squared minus 4 times 2/3 plus 5. I want to move that around. There we go. I don't think I want to deal with fraction. Let's type this in. Let's see, what was it again? It was 3 times 2/3 squared. 3 times parentheses 2/3 squared. Minus 4 times 2/3 minus 4 times 2/3, and then plus 5, I remember. There it is, 3.6 repeating. So, okay? So I go in and put 3.6 repeating here. Oops, got to make sure I'm drawing it. 3.6 repeating. There it is. There's my vertex. Axis of symmetry would be x equals 2/3. Yep, good job. That's my axis. All right. that's pretty much everything that's in 6.1. Okay, there isn't a whole heck of a lot there after that. You're just finding the vertex, minimum maximums, but minimum maximums is the vertex. Okay, it's going to ask you to do that, and I believe that's pretty much all of it for now. Okay. Questions on any of that we just did there? We probably have some questions on completing square. We'll do a couple more of those for the night's through. All right. Here's what I want to do. I want to go into the Desmos here. Okay. And hopefully you're with me. Are you with me? Okay. Y equals, I'm going to go like this. A, so like, okay, parentheses, x minus b squared plus c. A, B, C. Not using H's in case. When you do that, on the bottom of your equation, it says add slider A, B, C, all. Does everybody see that?
No, we can't see that. We can't see
No,
that.
you got to put it on. So if you don't have Desmos, you need to. Do you have it?
We're on Desmos.
Okay. So.
We can't
We
see
can't
that.
see that well enough to see.
Oh,
it.
you can't see the
Put it on
equation.
there,
Oh, okay.
because-
I understand what you're telling me. This is what we're typing in. That's what we're typing in. Sorry. Now do you see where it says all?
Yeah.
Yeah. Press all. Okay. What happens is it puts in A, B, C. A is 1, B is 1, C is 1, and it gives you the opportunity to manipulate those variables. All right? So, see if you can get B to be 0. I'm going to just slide it. I'm going to be able to grab it, and I should be able to just kind of slide it gently as best as I can to get to be 0. All right? I've got 0.1. I'm working. See if I can get it to be 0. Oh, I think I can actually tap it. You know, let me be. It might tap it, and it might let you take it to be 0. Yep, I can put 0 there. How about that?
Which one do you want, Sarah?
B.
B.
And I also want C to be 0. So I'm going to tap on that and let it be 0. Good. That's what I want. So A is 1, B is 0, and C is 0. All right? So now we have this. So what we're going to do is we're going to slide A around. And I want you to notice what happens to the parabola as you slide A around. So let's do that. So I'm going to grab that little circle in the middle, slide it around. What's happening to the parabola? It's getting wider until it flips. Okay? All right, so if I go all the way to the right, it's getting, what's happening to it?
Tight.
Yeah, tight, real narrow, right? Okay? What's happening to the A value then when that occurs?
Creases.
Decreases. Good. So if you increase the A value, then the parabola is going to get like this. All right? That's called a vertical stretch. You're stretching it out this way. Okay? What happens when it starts to get a little bit more towards the left and close to 0? Then what happens to it? Mine's at 0.3. How does the 0.3 compare with the 10? It's wider. Okay? So again, it's instead of being stretched, it's being compressed. Okay, so it's being compressed. And then, of course, when it's negative, what happens? It flips. All right? So the A value has that effect on a parabola. So I'm just going to kind of go into my little notes here, and I'm going to write this down. And then what I want to do is talk about how these things, notice I put it in vertex form, change the graph. So we said that A is what we call a vertical stretch. And you told me that the larger, how about this? You actually use the word increases. So as A increases, what happened to the graph? The graph narrows. Good, I like that. Narrows. So as A increases, the graph narrows. What happens when A is between 0 and 1? So it's kind of a decimal. Then what happens to the graph? What happened to the graph when it became a decimal? It widened. Good. So the graph widens. I don't know if that's a word, but we'll make it one. The graph widens. Okay? So if I want a wide graph, I change my A and make it small, close to 0. That's going to make it wider. What happens when A is negative? It flips. So the graph flips. And I'm going to say over the x-axis. Okay, so that's what it does, is it flips over the x-axis. So it becomes like a small letter N or something like that. Okay? Whereas when A is positive, it's a U. All right? Bless you. So that's what A does to the graph. Okay? I'm going to go back into the Desmos thing, so I'm glad that it's working here. And I'm going to tap on that A, and I want the A to be 1. So I'm going to delete stuff, and I just want it to be a 1. And now what I'm going to do is come down here and work with the B. And I want to see what B does to the graph. So what does B do to the graph? Yeah, it slides along the x-axis. Okay? All right. So
Mine just slides all by itself.
yeah, you must have hit the animation thing,
I like
right?
that button.
Yeah, that's kind of cool, huh?
She's getting a kick out of it.
Good. She's getting a kick out of a math thing. That's a good.
Right?
That's right. See? Okay. So what does B do again? Slides. And we want to say along the x-axis or horizontally. All right, that's what B does. All right. So I'm going to take it back. I'm going to change B. I want B to go back to 0 because I want it to be back to the middle. And this time I'm going to move C. And what does C do? Slides along the Y, or up and down. All right. So we could get them all going at one time, maybe. C slides along. You're having fun, huh? The y-axis. Okay. So what that does is that allows you to use these parabolas to model different types of situation, and which we're going to do here in a little bit. and I'm going to have you use these to model. Notice that it is in vertex form. All right. Okay, I don't even know where the heck it went now. It's disappeared. There it is. So it is in vertex form, not general form. See, general form won't tell us anything about the graph. That's why that form is the best when you're talking about graphing things, all right? So you want to stay away from general form. It just doesn't do us any good. Any questions about that transformation of graphs and parabolas? Because they're going to ask you some questions about that on 6-1. And also in 6-2. Okay, a couple things here, and then I'll let you take a little break. We'll be done pretty early, though. They're going to ask you to do some graphing. Y equals x squared plus 4. Okay? Now, I know that you could put this in Desmos and graph it and sketch the graph, and I would know the difference. Okay? But x squared plus 4, is that for your A, B, or C? And what does C do? How much is it going to move? How much is it going to move or slide it? Positive 4. Ta-da! There it is. Okay. All right. It's very easy just to know that stuff and to graph them. You don't even need to use Desmos or a graphing calculator or anything like that because you know what it's going to do. All right. Y equals negative 0.5 x parentheses minus 1 squared. What's the negative 0.5 going to do? Open down and make it a little bit wider, right? Okay? And what's the negative? What's the 1 going to do? Okay? Now, this is a little bit tricky because vertex form has a minus here, all right? And there's a minus here. So this 1 is actually how much it's going to move it. So it's actually going to move it that way, 1. Okay, you would think, oh, a negative 1 means I'm going to go back this way. No, not really. It's going to be the opposite of that. So it's going to move it this way 1. So we're going to have a graph. Looks a little bit like this. There we go. Opening down. A little wider than normal. Shift it over 1. Okay? Questions on that part? Just graphing them. Okay. We'll look at a couple of those. Let's do a couple more of these. Again, this is, they mention this in 6.2, but they don't ask you to actually do it. I don't see anything here where it's asking you to do it. But I would feel better if we did a couple more. Y equals x squared plus 8x minus 10. And what we want to do is write this in vertex form. Y equals a times x minus h squared plus k. Okay, we're going to complete the square on this. So we're going to do one of these. You told me that you did some of this in Math 60 maybe, or 65 I mean. So what was our first step when we did one of these not too long ago? What's the first step always in completing a square?
Add 10.
Add the 10. Move that 10 out of there. And this is kind of a complicated actually process or an algorithm, but once you do some of them, it's not so bad. You kind of get used to it. Okay, so we have x squared plus 8x. What's the next step?
Half of b squared.
Half of the b. I'm going to put that there. I'm going to circle it and square it. Very good. Okay, cool. What's on the left side? 26. Good. What is on the right side? Not 8. 4. That's why I always take half of this number, I write it there and I circle it. Because I know that's going to go right there every single time. And then I move the 26 over. Alright? So most likely, on a test, your final actually, you'll probably be asked to do a couple of them like that. I think it's important you know how to complete the square. I don't think it's necessarily like I'd have you do a bunch of them, but probably just a couple. Alright? So you should be able to do a couple. No. Let's do one more here, and then I'll promise I'll let you go. We should probably do one with an odd number, just in case it shows up. And then we got to do one with an a value. Okay, what's our first step here? Move that 9. Get it out of there. Next step. Half of b. So half of b that's going to be 5 or 2.5. Maybe you want me like put it as a decimal. And I got to square that. What is it? 6.25. Make sure we add it to both sides. So what do I get on the left side over here? 15.25 equals, what are we going to get on the right side? X minus what?
X minus 2.5.
2.5 squared. And then we're just one step away, correct? And from this, you should be able to state the vertex. Remember that it is always going to be the opposite. Okay? So this is your h here. This is a plus, and this has got to be a minus. But just drop straight down. Okay? A lot of people ask me, there might be some of you guys think about it. Where did this go? How come you can go from here to here? What happened to this? Remember, 2.5 times 2.5 is that. So if you take this and write it twice and FOIL it, it actually works out. Okay? It doesn't go anywhere. It's just being rewritten. All right? So when we come back, what we'll do is I want to show you how to complete the square when the a value is not 1. We'll do a couple like that. I really want to look over anything that you are not sure about in both of those sections. And then I want to do one quick little decimals activity to see if you can find the equation. And then we are done because we have a quiz, obviously, because we haven't any quiz on. Okay? Okay. I think there's one person. I don't know what it is. So here we go. We're going to complete the square write in vertex form. But this time we're going to make A something other than 1. Alright, so something like this. So in other words, this number here is not 1. So it's just not an x squared, it's got a number there. Alright? However, you're still going to pretty much do the same thing. What was the first thing we did? So we're going to move that 11 over to the other side. Alright? So now we have this. So we have y minus 11. The problem is that 2. So what I'm going to do is take everything in this equation and divide it by that 2. But I'm going to leave the left side alone. I don't want to touch it. I'm going to leave it just like it is. Y minus 11 over 2. I am going to divide the right side, so I get this and I get this now. Alright? So I took the 2 and divided by 2 and 8 and divided by 2. It doesn't matter if this is a 3, we divided by 3. If it was a 5, we divided by 5. We want to get this thing, so it's just an x squared. Now we can do exactly what we did before because we've already moved that constant over. So what did we do before? What would we do here? Half of b, which is? And then what do we do with that number? And notice I'm still going to add it over to this side. Alright? So I haven't done anything really different than what I did before. I got the 4. I put it way over here because I don't want it to have anything to do with that. Okay? And now I'm going to work on the right side only. So how would I rewrite that? Just x minus 2 squared, right? Okay, that 2 is going to go there. The minus drops down. Okay? Okay, so now what we're going to do is undo the division that we did up here. So I'm going to multiply everything here by this 2 to undo that division. So I'm going to multiply everything here by 2. 2 times the 4 is going to give me 8. But what happens when I multiply this 2 times this quantity here? The 2's are going to cancel, okay? Now this looks like it might be kind of complicated, but all we're really going to do is drop that 2 right out in front of those parentheses there. So that value that we divided by ends up sitting right out in front here. And now I just got to move things over. So I have y equals 2 parentheses x minus 2 squared. That'd be a minus 3, so I'd shuffle it over. That'd be a plus 3. And it's done. Okay? So really it's not a whole lot different, except you move the 11, you move your constant over, you divide, you work with the right side, you leave the left side alone until the very end, kind of.
Does the 2 affect the vertex at all?
No. Okay, that's a great question. What does this 2, you're talking about this 2, I assume, correct? This 2 is the same as this 2, okay? So they're both a's. In fact, if you look at those forms, this is an ax squared and that's an a. They're both a's. All the a's are always going to be the same. What does the a value do? Do you remember? Widens or flips, right? That's all it does. It does have no effect on the vertex. All right, so the vertex here would be 2, 3, axis symmetry 2, whatever they're going to ask you about. Okay. So that's how you handle that. All right. Again, I'd probably ask you to do a couple, maybe one of each, one where you have to divide, one where you don't. All right. So you might want to practice a couple of those when you're doing some of these problems. You can decide how many you want to do that way. Like, that's completely up to you. All right. So I kind of looked through these a little bit during break if there's something I thought you couldn't do, but let's go back and take a look. I didn't see anything. On page 426, the first problems are asking you to do 15 through 19, ask you to find the vertex, and it gives you an equation. Any questions on how to find the vertex of any of those that you see there? 15 through 19, this is on 426.
17. Yeah, 17.
Okay, let's talk about how you could find the vertex of that. All right? There's 3 ways. What's one way? Yep, what's another way? You could graph it. And what's another way? One more way. Negative b over 2a, right? Okay. Does that make it easier? Do you see what I'm saying? I wouldn't complete the square on this because of that 1/3 is going to be making a mess.
Yeah.
But you can still do it, right?
You could, but it would be a real mess. All right. So you can either graph it on Desmos and find the vertex, which I can do yet. I can show you. Right? Or you can use negative b over 2a. I would use negative b over 2a would be kind of a mess.
Yeah, negative b over 2a is a mess.
Yeah. So you probably just want to graph it, right? Let's see, then we did, let's see, 29, 25, 26, there's some graphs there, but you've done some stuff like that before, so, but if you have a question, we can do that, either 25, 26, any questions on those, or 29 through 30, or any of the other ones that you see on there. I think the next ones I just want you to find the vertex, graph, and evaluate. That takes care of us all the way up to into the 50s, which is, and then they want you to find the maximum. Any questions on any of those ones that you see on page 427 primarily? No. Okay. Okay. We're good then. You sure? Make me nervous. All right. 6.2. 441. 15 through 31 odds, asking you to sketch a graph. Identify the vertex. Compare it to y equals x squared. So in that case, you should talk about shifting, widening, narrowing, flipping, moving. All right? That's what they want. Okay, so you're comparing it to the standard regular old y equals x squared graph. Questions on that? $47, well, there's some of these other ones there. Let's see, what I lost there. 40, 35, 36 is the same. 41. 41 asks you to write the vertex form of a parabola that satisfies the given conditions, then write it in general form. So, for example, number 41 says the vertex is 3, 4, and the a value is 3. So what would that look like in vertex form? Vertex is 3, 4, and a is 3. So what would that look like in vertex form? Y equals 3 parentheses x minus, which is 3 squared plus 4. That's vertex form. Okay? Now they want us to write it in general form. So here's what we're going to do. We're going to write this twice. Okay? Foil it and simplify stuff. So probably want to do, excuse me, you want to do these first. All right? Foil that first. Forget that the 3 is even there. Plus 9, right? Okay. The 3's out in front, plus 4. Now I would work with the 3. Okay, bring it inside. And then combine these two things at the end. There it is. That's it. Sure. So you're just changing it from vertex form into general form. All right. We're going to foil it. Distribute that 3 or the a value, whatever that is, and add 4. Yeah, you can. And remember, a's are always the same. So this a, that a, going to be the same. Let's see, 47 through 50 is asking you to write equations again. 53 through 57 is finding the vertex, right, in vertex form. Probably complete the square on some of those. And then 61 through 67, write the equation in vertex form, so you can complete the square on some of those. Or you can always find the vertex using negative b over 2a or graphing it. There's lots of different ways of finding the vertex. Okay? Alright, so before we take off today, here's what I want you to do. I want you to go to Desmos, alright, and we're going to sign in. You'll see a sign in there. And when you click on that, I gotta click on it, so I can't quite remember what the terminology is that they use. Oh, it's gonna have email. Here's what you're gonna put: ROGERP at STHELENS.K12.OR.US. Okay, and then it's going to ask you, it says password, I think. PATTMATH. Okay. When you type that in, you log into my account. So let me know when you do that. Oh crap! Well, mine won't let you, but because I'm not in a, I don't have an internet thing, but that's okay. You guys do. That's all that counts.
It's at what? St. Helens?
St. Helens. Yep. Dot K12.OR.US.
So what do you want us to do?
There's a dot right here between the S and the K. Dot OR.US. There's the 3 bars. Once you get into it, there's 3 bars here, right? If you click on those, you're going to get a whole bunch of stuff, right? Some of you accessed this before, maybe when you did your McDonald's, because it's on there. If you go down, I'm going to have to look over your shoulder. Okay. Go down. It is called, oh. These 3 probably still something. problem quads 2. ALG2 problem quads 2. ALG2 problem quads 2. Right?
Picture of faucet.
Okay,
Picture of faucet
Okay. and
with
then
water.
Roger St. Helens dot what?
Roger P.
Roger
at
P.
sthelens.k12.or.us. So here's what you're going to get: a picture of a faucet,
Uh-huh,
okay, with water squirting out, correct?
right.
Yep.
Find the equation of that
Okay.
path of water.
This is
It's
our quiz.
superimposed. No, it's super. It's your. You get the equation. You show it to me, and you can go. Okay. All right. That's what I want to see. Now, if you don't have Desmos, find somebody who does, and you can work together on it. All right. It's superimposed onto the grid, so you can kind of estimate how to find it. All right. Yeah. And make sure you log out, though, okay, when you're done today, because otherwise the stuff gets saved on there, and I go, what the heck is this?